Hello everyone, my name is K. Reddy, working as the assistant professor in Tegal State Engineering College. Welcome to my channel. My channel name is Jackson Reddy for Research. This video I will explain power quality and fact subject. Okay, first I will open my playlist. This is power quality and fact subject. This all videos related to power quality and fact subject. Okay, this is now I will open syllabus. Okay, this is power quality and fact subject R18 syllabus JNTH. Okay, now I will explain this fourth chapter series compensators. I already explained objectives of series compensator and variable impedance type series compensator, TCSC, TSSC, operating principles and control schemes. Now I will explain this SSSC. Okay, this class I will explain this SSSC. Now I will start my presentation. Unit 4 static series compensators. I already explained this objectives of series compensator, variable impedance type series compensator, TCSC and TSSC. Now I will explain static synchronous series compensators. SSSC means static synchronous series compensator. Mainly static series compensators classified into two categories. One is thyristor based series compensator. Second one is converter based series compensators. Thyristor based series compensator classified into three categories: GTO thyristor controlled series compensator, thyristor switched series compensator, thyristor controlled series compensator. These three are thyristor based series compensators. Next, converter, voltage source converter based compensators, static synchronous compensator. In this thyristor based compensators used thyristors. In this converter based series compensators used converters. Okay, VSI. Now I will explain converter based series compensator. This is converter based series compensator, switching converter type series compensator. This is the circuit diagram. This is the transmission line. Okay, this transformer primary winding connected to the transmission line, series with the transmission line. Secondary winding, this is the step down secondary type. Secondary type step down connected to the, this is the voltage source converter, SSSC. Okay, this is the SSSC. Next, this is the voltage capacitor. Okay, this is the P is the active power sending both observing and injecting active power. This is the reactive power. This is the reactive power observing direction and the injecting and observing. Okay, active power and reactive power. SSSC only controlling reactive power. Okay, this is the energy source. This energy source optional. If we connected energy source here, batteries. Okay, if connecting batteries here, it controlling active power. Otherwise, only SSSC controlling reactive power. Okay, SSSC means static synchronous series compensator. This is the controller. This controller have here P reference and Q reference. P reference means the active power reference. Q reference means reactive power reference. When this energy source not connecting this energy source, this active power P reference is 0. Okay, when connecting this battery this battery here, we will give here P reference active power. Okay, this is the Q reference. Q reference means reactive power. This reactive power injecting when required reactive power. This reactive power injecting at the same time it observing. This is the both bidirectional symbol. This is also active power and reactive power. This is the control scheme. This controller it turn on and turn off switches in voltage source converter. Here, this voltage source converter. This is the coupling transformer. In this coupling transformer, this is the primary winding. This is the step down secondary winding. This is isolation. Okay, 4. Here, V is equal to V. V sine pi of t minus pi. Okay, this is the circuit diagram operation of SSSC. Okay, this is the static synchronous compensator basic model, basic two mission system with series capacitor compensation line and associated with phasor diagram. This is the basic diagram of series compensator. This diagram already in chapter 2. Okay, here injecting source converter. Okay, voltage source converter. In this here we are connecting series with the capacitor. Now I will explain the circuit. This is the supply voltage. This Vs is the sending end voltage. This Vr is the receiving end voltage. This Xc is capacitive reactance. This XL is inductive reactance. This Vc is the voltage across capacitor. This VL is the voltage across inductor. This I is the current flowing in transmission line. This is the P is the active power flowing in transmission line. Next power formula, power P is equal to B square by XL minus XC into sine delta. P is equal this V is the total voltage. Okay, sending end voltage is equal to receiving end voltage is equal to V. This V square by XL. XL means inductive reactance minus capacitive reactance into sine delta. This sine delta is the here this sending end voltage and receiving end voltage. The angle. Okay, this is the VL. This is the VC. This VC is injecting this capacitor. This VL is the voltage across inductor. Okay, voltage across inductor. When we are injecting this here capacitor voltage, the resultant is decreasing. Okay, here to here only. When we are injecting here capacitor voltage, the total inductance is increasing. This is the basic two mission model with the series capacitor compensation. Now this is the SSSC. SSSC means here injecting voltage source. Okay, here voltage source. This is the single line diagram. When connected transmission line, here three-phase voltage source converter connected here series with the transmission line. This Vs is the sending end voltage. This Vr is the receiving end voltage. This Vq is the injecting voltage. This PQ is the active power in transmission line. This I is the current flowing in transmission line. Okay, this is the formula. Power PQ is equal to active power V square by XL minus VQ by I. In previous formula, P is equal to V square by XL minus XC. Okay, here we are connecting series with the capacitor reactance. That's why here XC. Here power PQ is equal to V square by XL minus VQ. VQ means here injecting voltage by current into sine delta. Delta is the angle here, sending end voltage and receiving end voltage. This angle. Okay. Here we are injecting transmission line. This is the basic two mission system with synchronous voltage source. Synchronous voltage source means SVC, replacing by the series capacitor. Okay. In this capacitor, we are replaced by this here replace. We are injecting here voltage source. This is the SSSC operation, static synchronous series compensator operation. If you want watch these previous classes, okay, subscribe my channel and watch TCSC and TSSC, okay, previous classes. Okay, thank you for watching this video.